So now we'll take a look at creating an animation of a curtain. We'll use some basic keyframing first, then we'll go in and add some fields and go in and paint some weights. So let's start with the animation of just the curtain. Alright, let's open up the paint weights lesson here. And it's just a basic curtain that I have built, no animation. So let's set some keyframes. Okay. So here's my basic animation. Okay. It's a little circle. Alright. So to this, I'm going to go ahead and make this a soft body. And we're going to create, make a duplicate, make it soft, and then hide the non-soft, hide the make it gold. Okay, so we'll create. Now right now, nothing's going to happen. Everything is going to be the same because we have a goal weight of 1. And let's just select this object, go in and paint our weights. And let's see, we'll set this to replace, and we'll just go here and paint this bottom set here. Alright, now let's take a look at how this reacts differently. Okay, so you see how this is reacting differently? We have this jiggle or this undulation. Alright. And that's how you can get yourself a very, very simple animation. Now let's take this a little bit further. We'll select this particle cloud and let's add a turbulence field. Alright. And we'll set the magnitude to 100, attenuation to 0, so it happens throughout the system. Okay. Let's actually set this attenuation to 5 so it kind of tapers off. Okay, just a little bit of noise there. You can see how this bottom kind of chattered. Alright, but if you look, it still acts kind of funny. There's something not right about it. Well, what we need to do now is introduce something called a spring. Okay, so we'll open up the option box. And you can add to existing springs. We're not going to do that. We're going to set this to creation method to wireframe. And wire walk length, what that means is how many are of these particles that is it going to be connected to. So right now it's set to 1 each one. So what that means is when this particle moves, it's going to move its neighbor. Let's set this walk length to 2. All right. Now we can use a per spring stiffness and a per spring dampening, or we can use one stiffness and dampening for the whole thing. We'll just use one whole setup here. And you see how that's trying to hold that shape? Let's play this again. Now we can increase this dampening. Now watch what happens. Okay, I'm just going to keep increasing this until we blow up the simulation. Well, it's keeping up. Now let's see if I can. What I'm trying to do is get it to where it can't keep up with what I'm trying to ask it to do. And particles will just go all over the place. Alright, so let me see if I can adjust my paint weights here. Okay. Alright, there we go. We got it to blow up there. So what's happening? Why did it do that? Well, there's too much data for the system to keep up with. So what happens is, because we made those changes in our spring and our weight, goal weight, it didn't know how to deal with that. So you're going to have to open up the solvers, edit oversampling, or cache settings. And with that, we can actually increase an oversample. Let's see, we need to modify playback speed. Alright, let's try this. You notice how it kept that animation going. Okay. Now, anytime you increase the oversampling, you're going to slow down the system big time. So keep that in mind as you're working, that you may want to reduce the some of the settings in your spring, things like your dampening and stiffness, prior to just changing the oversampling. So if the thing just kind of blows up, keep that in mind as you're working. Next, I'll talk about how to turn lattices into soft bodies.